Good evening, fourth grade. Going to work today on naming and modeling multiples of unit fractions. Lots of vocab in there. Naming and modeling multiples of unit fractions. So go ahead and write this down as the title of your next lesson in your math notebook. When you have done so, mark your page, close your notebook, and just listen and give me your full concentration for the I-dos. Alright, so a couple quick reviews here. First thing, if we're going to learn about multiples of unit fractions, let me remind you what a multiple is. We did this earlier in the year, but never hurts to review. So let's say the multiples of, say, 7 are 7 times 1, 7 times 2, 7 times 3, 7 times 4, 7 times 5, and so on. Any number like that, so 7, 14, 21, 28, and 35. Those are the first 5 multiples of 7. So we would say like 21, that is the third multiple of 7. And 35 is the fifth multiple of 7, right? And sometimes we can list them. You know, the 10th multiple of 7 is 7 times 10, which is 70. That's the 10th one. And so on. We can find any number multiple you want. Sometimes we don't make the whole list. Like I might ask a question like, what is the 20th multiple of, I don't know, 15? So, you know, the multiples of 15 are 15 times 1, 15 times 2, 15 times 3, and so on and so forth. And so if I want to find the 20th multiple of 15, I would multiply 20 by 15. I would probably use an area model, and I would get 200 and 100, and the 20th multiple of 15 would be 300, because 20 times, if I went all the way out here, 20 times 15 would be 300. So that's what a multiple is. Another vocabulary word that was in there was unit fraction. And let me remind you what a unit fraction is. That's any fraction where the numerator is 1. So like 1/3 is a unit fraction, 1/7 is a unit fraction, 1/12 is a unit fraction, 1/100th is a unit fraction. Any fraction where if you made it with fraction bars, you would make 1 bar. You know, 1/3 bar, 1/1/7 bar, 1/1/12 bar. That's a unit fraction. So today we're going to talk about multiples of unit fractions. All right? So let's talk about the number 7/5. So where 7/5 relates to unit fractions, I'm going to look at my denominator. The unit fraction of fifth is 1/5. That's a unit fraction. Man, that pen is not writing for me. Fraction. Sorry, that's a little sloppy. So 1/5 is a unit fraction. And just like a number, fractions have multiples. So I would say the multiples of 1/5 are 1 times 1/5, 2 times 1/5, 3 times 1/5, 4 times 1/5, and so on. So those will be the multiples of 1/5. And we spent a lot of time the last 3 days on strategies to do that. So 1 times 1/5 is 1/5. 2 times 1/5 is 2/5. 3 times 1/5 is 3/5. 4 times 1/5 is 4/5. And so on and so forth. So I can look at a number like 3/5, and I can say that's the third multiple of 1/5, if I wanted to say it like that. So when I look at 7/5, I know that if I were to go out here farther, that 7/5 is equal to 7 times 1/5, and that it is the 7th multiple of 1/5. So that's really the main two things. I'd love for you to be able to look at a fraction and say two things about this. So I looked at the number 7/5. I want you to know, first of all, that I could rewrite that as a whole number times a unit fraction. That all 7/5 means is 7 times 1/5. And that is the 7th multiple of 1/5. All right, so that's just some straight math dealing with multiples and unit fractions. So we'll come back to one of those on the we do, where we just kind of think about the number and what it's a multiple of and where it came from. But I do sometimes there are problems that involve something related to this. So let's look at this. So here we say Lisa invited a few friends over to her home for pizza. The 3 pizzas that Lisa's parents ordered were each cut into 6 equal slices. Let's do that. 1, 2, 3. When Lisa and her friends were finished eating, there's no number there. That's weird. It's supposed to say 7/6 of a pizza were left over. 7/6 of a pizza were left over. How many slices were left? So if we look at our diagram here and we say, well, when we're all done eating, we're left with 7/6 of a pie. That would be 1. This is 6/6. If I color one whole one, that is 6/6. And I would need one more 6th to get 7/6. So now if I color that in, I'm now showing a remaining, that's 1/6. And together those make 7/6. And so the question is, how many slices were left? So I'm taking this problem and I'm dealing with the number 7/6. If I know that 7/6 equals 7 times 1/6, or that 7/6 is the 7th multiple of 1/6, then it's very easy to say, well, since they're sliced into 6, if there's 7/6 left, that really just means, the question is how many slices were left, that really just means there's 7 slices. Right? My knowledge of multiples tells me that 7/6 means 7 slices since they're cut into 6 pieces. All right? So that's just kind of how like a real problem involving that might work out. Let's do a couple together. Open your notebook. We'll do one with just numbers, and then we'll do a situation. All right? So let's look at the number 9/4. So based on what I taught you, there's I kind of want to think of 2 big pieces of knowledge coming out of this fraction. 2 things you understand about this fraction as a mathematical thinker. So before I say what they are, let's deal with this. So one thing I'd love for you to know, so this 9/4 is made from the unit fraction of 1/4. So I'd say it's made from, its base unit fraction is 1/4, right? And the multiples of 1/4 are 1/4, 1 times 1/4, 2 times 1/4, 3 times 1/4, and so on. So the multiples of a 4th are 1/4, 2/4, 3/4, and so on and so forth. So now I could look at any of these and say, 2/4 is the second multiple of 1/4. 3/4 is the third multiple of 1/4. And so then when I get to my 9/4 out here, which is what I'm dealing with, I can look at 9/4 and I can know 2 things about it. First thing is that it comes from 9 times 1/4. That's how I would make 9/4. And that it is the 9th multiple of 1/4. So those are really the big two things I would love for you to say when you see a fraction, to be able to say two things about it and say, one, I know that this is 9 times 1/4. And two, that this is the 9th multiple of 1/4. All right? And that's where that kind of comes from. So all this was just going to work to get me to those 2 points. I know that it's 9 times 1/4, and I know that it's the 9th multiple of 1/4. Okay? Let's do a question that involves this skill. So if you want to go ahead and pause and write down the question, and then you can either work it on your own, or you can unpause and work it along with me, but go ahead and at least pause and write the question down in your book. All right, so Emma made a New Year's resolution to walk 4 miles per week. 4 miles per week by completing 1 1/4 mile loops through her neighborhood. After Friday's over, she's walked a total of 2 1/4 miles for the first week. How many laps does she need to walk over the weekend to meet her goal? So Emma's goal is to walk 4 miles. 1 mile, 2 miles, 3 miles, and 4 miles. And since I know her loop is 1/4 of a mile, she's just going to walk that loop over and over again until she gets to her 4 miles. I'm going to go ahead and divide my miles into fourths. There we go. So now that's what she's done. So it says when Friday rolls around, she has already walked a total of 2 1/4 miles. So when we get to Friday, she's walked 1 mile, she's walked 2 miles, and 1/4 mile. So this is what she's done during the week. So notice my question. My question is, how many laps does she need to walk over the weekend to meet her goal? Not how many miles, how many laps. So I can look here and say that she has 1, 2, 3, 4, 5, 6, 7/4 left to go. 7/4 remaining that she has not walked. And I know that 7/4 is 7 times 1/4, and that 1/4 is how far each loop is, right? That's why I'm going into that unit fraction. So since I know that 7 times 1/4 makes that 7/4, that tells me that she has 7 laps to go. 7 laps remaining. And I can see those here, right? 1, 2, 3, 4, 5, 6, 7. Since she's walking 1/4 mile loops and I divided these into fourths, each one of these space represents 1 lap, right? 1 lap. 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 So up till now, we would have always looked at that and just thought of that as being 1/4 of a mile, but we can also think of it as being 1 remaining lap. Okay? And so she has 7 laps to go. She has 7/4 of a mile to go, 7/4 miles, and that is 7 laps. So that's how multiples of unit fractions work, how you can think about them, and how they help you solve problems. If you need to go back and look at either example again to have a good idea of how this works, please do. When you've got this written down, drawn, and you feel like you totally understand this for class tomorrow, you're all set. Can't wait to see you then.